Hello everybody, good morning. We're going to tackle a particular problem. It's very famous in interviews it seems. It's lead code question number 80. This is the problem description of it. Given an integer array num sorted in a non-decreasing order, remove some duplicates in place. Point to remember. Such that each unique element appears at most twice. Point to remember. The relative order of the element should be kept the same. Point to remember. The last two lines, let me read it out. Since it is impossible to change the length of the array, you must instead have the result to be placed in the first part of the array nums. More formally, if there are key elements after removing the duplicates, then the first key elements of num should hold the final result. Example. Without example, we can't, it's very hard to elaborate such things, alright. It says that you have an array 1, 1, 1, 1, 2, 2, 3. Your final array would be 1, 1. You cannot have more than 2 repetitions of one particular element. 2 is anyway repeated twice, so it is acceptable. 3 is repeated only once. 3 is not repeated, there's only one 3. So this is your final output. All the other elements, right? All the other ones can come here. All the other ones. If there are any other 2's can come here. If there are any other 3's that can come here, doesn't matter. Because you can't really shrink or expand the original array. You're not doing that. You're doing an in place, meaning you're operating on the same array without using an additional space complexity, and your target is to your desired outcome should be present in the first part of the array. See, this is the first part of the array. Which one? This is the first part of the array. Yes. How many elements? 1, 2, 3, 4, 5. So you'll return 5. So what that would do, the checker would understand, okay, now the array, initial array was this, the final array is now this, and I have to only look at the first 5 elements to understand whether the candidate who has written the solution got the desired outcome or not. I hope this is understandable. Now how do I come out and give a solution to this? I think writing the actual code will come later if time permits, but my main focus is on explaining things, alright? So I'll get down to that. 1, 1, 1, 1, 1. How many ones? 5 ones, I believe. Then 2, then 2, then 2. Understand, I will have a 2-pointer approach. One I will call fast variable, one I will call slow variable. Yes, and I will have a counter. Yes. Try to write the solution on your own if you can. If you think that you would want me to give a solution, I would definitely like to provide that, but let's get on to the concept. I will use my fast pointer because fast will move ahead. It will actually iterate the array. Slow pointer is, the main purpose of slow pointer is to move from one index to the other, but it might stop on a particular index based on a certain condition. I'll say that, hey fast pointer, you're at index, this is the index, right? 2, 3, 4, 5, 6 and 7. Hey fast pointer, you are at index 1, your element is 1. What is the element right before you? That is also 1. So right now we have 2 similar elements. So counter is 2. Counter basically tells how many similar elements with respect to the fast pointer. 2 similar elements, right? Since it is 2 similar elements, I'll say, hey, that's okay, 2 is acceptable. Fast pointer, slow pointer, please both move to the next element. Again the same thing, hey fast pointer, you are at element index 2, your element is 1. What is the element just before you? So the element at index 1 is 1. So both are same. So right now the counter tells me that we have 3 consecutive elements. Yes, I hope there are no confusion. Alright, but this is a problem. You cannot have a unique element repeated 3 times. So when the counter increases to 3, what you do, you say slow pointer, stop, don't move. Fast pointer, you move. Only fast pointer, you see? When the counter is more than 2, slow pointer stops, fast pointer moves. Now, again the same check. Hey fast pointer, you are at index 3, your value is 1. The element at index 2 is also 1. So now with this you have a counter of 4 consecutive elements. Horrible. Slow pointer, you still stay. Fast pointer, you still move. Fast pointer moved over here. Hey fast pointer, you're at element 4, element index 4, element 1. At index 3, just before you, the element is still 1. Oh my goodness, sorry, this is 4th index. So the counter is 5. Why 5? 5 consecutive ones. Right? Slow pointer, you still stay, don't move. Fast pointer, you move. Now the situation is a bit different. Now, the same thing. Hey fast pointer, you're at index 5, your element is 2. Just before you at index 4, the element is 1. You, both of you are not same. You are 2 and right before you is 1. So first thing first, right now, the number of unique elements pointed by F or fast, the fast points to the element 2. How many unique elements are there right now? 1. So counter gets initialized from 5 to 1. Because right now you only have one, you can only see one occurrence of the element 2. And what you do is you say, hey 2, please don't stay over here. Let me put this in red so that it becomes a bit clear, I hope. Hey 2, you don't stay over here. Wherever is slow, you come over here. So this one now becomes 2. This remains 2. It actually shouldn't remain. It should be a cut paste. It should go disappear and it should come over here. But we are not removing it. We're just having a copy of this in this place, right? And then what we say in black, hey fast, you come over here. Slow, your job is done. Thank you. Can you need an eraser, need an eraser, need an eraser, right? Need a small eraser. Anyway. Slow, can you come over here? Yes. Now 2. Fast is over here. Hey fast, you are pointing at index 6, your element is 6. Just before you, what was the element? 2. Both of you are same. But you could say that this is not good. You actually don't have an element over here. Yes, I don't have an element over here because I moved it from here to here. But when I'm saying that I'm comparing this with this, isn't it the same thing as saying I'm comparing this with this? But I don't know actually where this would go. It could go over here. On a different example, it could jump to a different place. So I'm not very sure where it will jump to. But it is always a guarantee that when I compare this with its previous element, it is as same as saying I'm comparing this with this, right? So I'm always saying that, hey, fast, you are now here. Tell me, you are pointing to value 2. Just before you, what element do you have? 2. Oh, great. So your counter is 2. What does counter tell you? That right now I can see that there are 2 repetitions of the element 2. Cool. When I see this, what do I say? Hey, slow pointer, can you please in red take this and paste it over here? Because this one cannot be there. Think about it. Your desired array 1 1 acceptable, 1 2 just one repetition of 2 acceptable, but these ones cannot be here. So these two, this particular 2 now gets should basically get copied from here and it should come over here, right? After coming over here, what you should do, you should say, hey, slow, your job is done, come over here, and fast, your job is done, come over here. And then again the same thing, hey, fast, you are at element 2, just before you the element was 2, cool. So the counter has now increased to 3. Once it has increased to 3, what would I do? Should I copy this or should I not copy this? I won't copy this because right now when fast was over here, what is my current state? 1 1 2 2 1. Slow is pointing over here, and then 2 2 and 2, and your fast is over here, right? And your counter is 3, meaning there are 3. Right now you can see 3 consecutive 2s. These 2 2s actually have been copy pasted over here, isn't it? Now Do we want to copy this? Do we want to copy this 2 over here? No, we do not want to copy this 2 over here, because there can only be 2 repetitions of a single or a unique element. So what would I say? Since the counter is 3, hey, fast, move to the next element. You have reached the end of the array. So right now, your actual array is this one, 1 1 2 2, and slow is over here. Slow is at here. So if you return slow, or if you return s as the length or s as the index, I think you will get your desired output.